Hi, I'm going to show you today how to draw an Euclidean geometry problem with Fusion360. You will see this has a great benefit. It's easy to animate the figure. So let's start. This is the problem that we want to solve. You see, we have two squares, one here below, one on the top. These two squares are the same. They are connected by this parallelogram, and on the parallelogram we build other two squares. Then we connect the center of each square, and the figures that comes out, K, F, E, M, it seems a square. So we want to prove that it is a square. Before starting the proof, we would like to be reasonably sure it's a square. So we may draw it several times in different configuration, but we will follow a different path now. I will show you how to do it with Fusion360. That's a typical parametric CAD. So the final result will be something like this. This is the figure, you see. But what's nice here is that I can change it. You see, I change one square dimension, and all the other dimensions change. What I want to know if this inside is always a square. So let's test right now. For example, we select this line, shift click this line, angle 90 degree. Oh, this line and this line 90 degree. Let's check the length just to be sure. 11/16. The measure is in inches. I don't know how to change it now. So let's see the other one. Okay, the length is the same. We're sure this is a square. Let's change other dimensions. For example, this height. You see? Let's make it a bit more extreme, like this. And let's check again, it's a square. So the angle between this one and this is 90. You see here. Let's check the angle between this one. Well, it's useless to check. Well, let's check it. It's 90 again. The length of this is 764, and again 764. Good. So let's see how to do this drawing, how to build it in Fusion360. Sketch, create sketch. Let's select a plane. Okay, let's build the square first of all. It is convenient to do everything with lines. So Command L or L directly creates a line. Ask L, ask L. Good. Let's put it together. And now apply some constraint to make it be a square. So between this and this, the constraint is perpendicular. Bam. This and this, perpendicular. This and this. I don't say perpendicular. Perpendicular again. Then we want this line and this line to be of the same length, equal. So this is a square. You can see it. I try to change it, remains a square. Good. Let's build another square. Okay, line. Line. Must be careful not to add constraint automatically that we don't want. Okay, this line and this line again perpendicular. This line and this line perpendicular. Whoa, whoa, whoa. And this line and this line. Okay, this side and this side are equal. Okay, let's say then this and this are parallel. Okay. Then we want this side and this side to be equal. Bam. Good. Let's connect the lines. This goes here, this goes here, this goes here, and this goes here. Now let's build squares over these two. So line. And some more lines. Let's build. Bam. Polygon closed. Okay, let's put some constraint. This and this are of course perpendicular. These and these are of course perpendicular, and of course 2 again. Good. Then this side and this side are equal. Good. It's a square. Let's build the same structure here. Okay. You see, this constraint, it's unwanted. You must be careful with automatic constraint. That's why I put each line independently in the free space with apparently no constraint, and then I build the constraint one-to-one. So, for example, this figure, we want to be a square. We want it to be a square, but we want it to be a square through constraint. So this line and this line perpendicular, this line and this line nope, this line, damn it, this line and this line are perpendicular, this line and this line perpendicular, this line and this line must be same length, so equal. Good. Let's try to move our figure and see a bit what happens. Oh, oh, oh. Let's shrink this. Okay, maybe bring this a bit upward. Maybe we may fix one constraint. This point we want it to be fixed here. Yeah. Okay. So you see, so nice. This is our figure moving. Let's try to shrink this. Beautiful, huh? Okay, we need another thing to build our our final construction that we need to prove it's a square. So we need to build the center of each square. I do with an explicit construction. So let's do it again with a lot of lines. There is probably a shortcut to do this, as there was to make multiple squares, but I prefer to do the construction myself, to be sure the drawing represents what I want it to be. So we need the center of this square. Bam, bam. Bam. We mark this as construction line X. So by now I press X and this is also construction line. So let's do the same here. X, X, hope, x, x. Okay, other two lines. Okay. Construction line. Construction line. Good, let's move our figure and see if everything goes well. Is the center of the squares move well, and they do. Okay, so everything is well constrained. Finally, let's build our central square. So this goes connected to this, which is connected to this, which again goes here. Let's move it. Ugly, but working. You see, it's quite pretty. So let's stop at one moment and check it's a square. So this line and this line angle 90 degree, good. And this line 564 length, this line 564, so this is a square. Let's move it again. This line and this line angle 90 degree, length 1564. Is definitely a square. Good. The next thing to do, of course, is to solve the problem, but this is maybe will be a subject for another video. That's it. Bye.